All right, today we're doing area of a regular polygon. You'll need a separate sheet of paper to take your notes on. Remember, if I go too fast, feel free to pause the video so you can get everything written down. You will also need a calculator in front of you. Your phone calculator will be fine. We just have to do some trick today. So our learning target 5 is I can find the area of a regular polygon. Before we dive into what the formula is and how to find it, we need to know some pieces of information. So the first one is we're going to use the letter A to represent the apothem. Okay. The apothem is a segment from the center to the side, and it's perpendicular. So if I were to draw that in my diagram, I would have the center of my pentagon right here. If I draw it straight down to the side and create a 90-degree angle, that is my apothem. I can label that A. All right, so what I want you to do is I want you to take a look at the diagram. I want you to think about a way we could find the area of that pentagon. Maybe think of a shape that we really like. So hopefully you thought of a triangle. If I bring this down and I bring the other side of it over here, I have a triangle that uses the whole side of the pentagon. Okay. And what I want you to think about is how many of those triangles are in this pentagon. There are 5 whole triangles because of the 5 sides. So if I were to draw it in, there's 5 whole triangles. So the idea is if I can find the area of one triangle, all I have to do is multiply by 5, and that equals the area of the polygon or the pentagon. Okay. But the deal is I don't have a lot of the other pieces of information. So instead of looking at the 5 whole triangles, we're going to take a look at this triangle. And the reason why I want to look at that triangle is because it is a right triangle. And I have tools in my toolbox with right triangles where I can find the other side length. So instead of looking at 5 whole triangles, what I'm going to do is I'm going to take the area of a right triangle and I'm going to multiply it by 10 to get the area of the polygon because there are 10 halves inside this polygon. If I were to cut them all in half. Okay, and again, the reason I'm looking at halves is because it's a right triangle, and I have tools in my toolbox to find side lengths of right triangles. Things like SOHCAHTOA and Pythagorean theorem, and even special right triangles. Okay, so what we're going to do, this is our game plan, right? This right here is how I find the area of the polygon. I don't want to have to go through those steps every time, so maybe if I do it very generalized, we'll come up with a formula that's just for polygons. So that's called deriving. We kind of talked about that a little bit in another video. We're going to do lots of deriving the rest of the year. I'm not going to just give you a formula. We're going to derive it so you understand where the formula comes from and why it works. Okay, so again, we know our game plan. We need to find the area of a right triangle and then multiply it by 10. Okay, so let's take the area of my right triangle Any triangle's area is going to be 1/2 the base times the height. We learned that earlier in this unit and another one. Okay. All right. So my base of my right triangle is right here. Okay. What we're going to do is, because we're finding the polygon, so let's focus on the polygon. This is the side length for the polygon. Okay, so that means side length. S for side length, because I don't know how long it is, so I'm going to use the letter S. Okay, S is going to represent the whole side length of the polygon. The base, I need to find something to represent that. So remember that big triangle I drew? Its legs goes from the center to the edge of the circle. That's why the pentagon is inside the circle, okay? Because these are the radii, and they're equal, which makes that whole triangle an isosceles triangle, which means when I draw the altitude that I have here, or the apothem, 90 degrees with the base, it also cuts the base in half. That is a property we have learned. So, the base of my right triangle is the side length divided by 2. Okay. So I know my base, because we're going to fill in the base and the height, is the side length divided by 2. Because it's an isosceles triangle, the legs are congruent, because they are the radii. That makes the altitude or the hypothum go through the midpoint and cut the base in half. So if the whole base is S, then this half has to be S divided by 2. Now I need the height. The height of my right triangle is here. And remember, we labeled that A for apothem, so that's going to be my A. Okay. Now I'm going to simplify this down a bit. Okay, I have 2 fractions here. I'm going to do some work off on the side. I have 1/2 times the side over 2. Okay, remember when we multiply fractions, we multiply across, so the tops multiply. 1 times S is just S. And I multiply 2 times 2, which is 4. Okay. Now, one thing you guys should know is I could pull that S out of the fraction just like that. Okay, whatever is on the top of a fraction can be pulled out and multiplied like that. Okay, and I'm going to do that just to be simplified, okay, so that my S isn't in a weird spot. So I'm going to have 1/4 times S times A, my apothem. So my side length times my apothem. Okay. Now, that is the area of my right triangle. I need to find the area of my regular polygon. Okay, so RP is for regular polygon. I want to write that off to the side. Okay, so this is where I'm going to pause. We did come up with a game plan, but this is very specific to just pentagons. Okay, we know in pentagons there's going to be 5 whole triangles, which makes 10 half triangles, so 10 right triangles. But let's say if it was a hexagon, I would have 6 whole triangles, which would give me 12 right triangles. Okay, so hopefully you're seeing a connection. What do I do to 5 to get 10, and what do I have to do to 6 to get 12? Yeah, I just have to multiply by 2. Now, the 5 and the 6 represent how many sides I have in a polygon, and if you remember, we like to use a letter for that, okay? N always represented this number of sides in a polygon when we did our polygon unit in the quadrilaterals. So what I'm really doing is I'm taking the number of sides and then I multiply by 2 to get how many right triangles, okay? I don't want to use 5 or 10 in my deriving of the formula because that's only specific to pentagons. I want to use something that's more general for all polygons. So I'm going to take the number of sides and I'm going to multiply by 2, and that's going to tell me how many half or right triangles I need to use. Okay, number of sides times 2 gives me the 10, right? So instead of using 10 times the area of a right triangle, I'm going to take 2n. Okay, and maybe you want to write over here 2n represents number of right triangles in any polygon. Right, and then n is just the number of sides. Also, a reminder, just in case if you don't know, you don't have to do this. What the deriving part that I'm doing is not how you do the problem. It's just going to give us the formula, and then we'll use the formula. Okay. Now remember, we said we're going to multiply that times the area of our right triangle. Okay. Well, we found our area of our right triangle to be 1/4 the side length times the apothem. Now I got to do some combining. So what I'm going to do here is I'm going to take the numbers. So I have 2 times 1/4 and multiply that. Now all whole numbers are over 1. So now I can make it a fraction, multiply the tops together, multiply the bottom, reduce this down to 1/2. Okay, so that becomes 1/2. And then I have n times s times a. Okay. So far so good. But we can simplify this a little further. We can make it a little easier on ourselves. If I take the number of sides times the side length, what kind of unit does that tell me? Okay, so let's say in this pentagon, each side length is 7. Okay, if I take each side length is 7, remember a regular polygon, those are all equal. Okay, so all sides are 7. And I multiply it by the number of sides, which is 5. It gives me 35. That's like taking 7 plus 7 plus 7 plus 7 plus 7. What that gives me is the perimeter. For perimeter. Okay, so when I see in a formula that I have the number of sides times the side length, that is going to be perimeter. The perimeter of a polygon, all I have to do is take the number of sides I have, n, and multiply it by the side length. Okay, so if I have a square and all the sides are 4, to find the perimeter, I just have to take 4 times 4, and I get 16. Or I can take 4 plus 4 plus 4 plus 4 and get 16. So the multiplying is the shortcut, the quick way. Okay, so again, side length and number of sides. Okay, so instead of putting n and s here, I can change that to be a capital P for perimeter. And that is how we find the area of a regular polygon. You just have to take half times the perimeter of the polygon times its apothem. I know that was a lot of work. You'll never have to do it again, but hopefully that kind of helped you understand where that formula comes from. If that was really confusing to you, as long as you can use the formula that we got, you should be good to go. If you want to understand this, feel free on the Google Meet to ask me and we can go through it again. All right, so let's use our formula to find the area of this pentagon. Okay. Remember, the area of a regular polygon is 1/2 the perimeter times the apothem. They give me A, they give me the apothem. Okay, I have to remember that A is from the center of the pentagon straight down to the side, making 90 degrees. And if I connect it like that, I have a right triangle. Okay. So when I go to find my area, I'm going to take 1/2 the perimeter times the apothem. I know the apothem is 5. The problem is I don't have the perimeter. Well, to find the perimeter, we take the number of sides times the side length. Well, I have a pentagon, so the number of sides is 5. But I don't have the side length. Okay, so I need the side length S here. I have a right triangle. And again, we already talked, remember, that when I draw this triangle, these two sides are the radii, and they're going to be equal to each other, okay, creating an isosceles triangle. So when I draw that upon them, it not only is 90 degrees, but it cuts the side length in half. So if I can find x here, all I have to do is multiply by 2, and it'll give me my side length that I'm looking for. Okay, and remembering that I have a right triangle here. Now, I only have one side length of that right triangle, and the only way for me to find another one is if I have an angle measure. Okay, I can't use Pythagorean theorem because I only have one side length. Pythagorean theorem is when you have two side lengths and you're finding a third. So I can either use SOHCAHTOA or special right triangles, but either one of those, I need to know that there's an angle measure. I need to know there's an angle measure of 30 degrees or something. So another piece of information you need to know is how to find this angle right here. Theta. Remember, theta is just like an x. Okay, so need to know which is just the top angle. Okay. What I want you to realize is if I were to draw all the triangles in again, okay, all the angles around create a circle. And we know a circle is 360 degrees. Theta here is 1 out of 10 pieces of angles, because remember, we're cutting these in half. So each one of these is a theta, and there's 10 of them, okay? So what you can do to find it is just divide by the number of sides. Okay, when you divide by the number of sides, that will give you this whole angle here. Okay, this piece for one triangle. But remember, theta is half of that, so I have to divide by 2. Theta is only half of the whole. Okay, so to find that top angle, to find theta, I take 360, divide by the number of sides, and then I divide by 2. Okay, so in this case, for our problem, I'm going to take 360, divide by 5, because I have 5 sides depending on. And then I'm going to also divide by 2. And it gives me 36 degrees. Okay, so theta right here is 36 degrees. Now I can use SOHCAHTOA to find x. I have the adjacent side and the opposite. Okay, opposite and adjacent, if I use SOHCAHTOA, if you guys need to write that out again. Opposite and adjacent is tangent. So I take tangent of 36, my opposite x over my adjacent, which is 5. Solve for x, I just multiply 5 on both sides. And x is going to equal 3.63. But remember, to find the side length, I need to multiply by 2. So I'm going to multiply that by 2. I get 7.26. So now I have the side length is 7.26. There's a lot of steps to these problems. I know. I know it's a lot, but it is what it is. I got to teach it to you. All right, so if my side length is 7.26, again, remember, we're still trying to find perimeter. Okay, so to find perimeter, it's the number of sides times the side length. Oh, I have it over there. Silly. Okay, number of sides times the side length. I have my number of sides is 5, and now I have a side length 7.26. When I multiply that together, I get 36.33. Now over here, I can put that in, 36.33. All I have to do is put this on my calculator and multiply. It's okay to give me a decimal because there's no pi in this problem. 90.82 units squared. Okay, so that is an example of when I give you the apothem, how to find the area of a regular polygon. You'll have to find the side length first, and then you can find perimeter, and then you can find the area. I know it's a lot of steps. Let's try another one. Okay, in this one, I want you to find the area, but instead I give you the perimeter. So remembering, my area of a regular polygon is 1/2 the perimeter times apothem. Okay, so I need to put the perimeter in and the apothem. They give me the perimeter, it's 35, which means I need to find the apothem. Okay, so from the center down, that's my A, that's what I need to find. So I draw in a right triangle. If I have any hopes of finding that A, I kind of have to fill in some things in my right triangle. So let's start with trying to find a side length of it, so like a base here, okay? To find that, I know I just have to take S and divide by 2 because these are going to be equal to each other. Okay, so I need to find my side length first. I gave you perimeter. Remember, perimeter is the number of sides times the side length. So my perimeter is 35. I know I have 5 sides, so I have to find my side length. My side length is 7. So this equals 7. And if I cut it in half, each piece is 3.5. All right, so now I have A, and I at least have one side of my right triangle. So all I need now is an angle, and then I can find my apothem. So again, we're always going to find this angle up here because we know it creates a circle all the way around. So to find theta, remember we take 360 divided by n and then divide by 2. So I'm going to take 360 divided by the number of sides, which is 5, divide by 2, and I get 36. Exactly the same as I got last time because they are both pentagons. So you know in a pentagon, that theta, this piece here, is always going to be 36 degrees. Always. All right, so now to find my apothem, I'm going to use this angle. My apothem is the adjacent side, and this is my opposite side. So again, using SOHCAHTOA, I can do tangent of 36 degrees equals my opposite, which is 3.5, over my adjacent, which is my A, my apothem. And if you remember, this was exchange-o, change-o. You just got to switch those around to solve. And all you have to do is type that in the calculator, and you get 4.82. So my apothem over here is 4.82. Now all I have to do is multiply all that together. Again, it's okay to give me a decimal because there is no pi in the answer. That's units squared. Again, make sure you put squared. We are in the area of unit. I'm taking 2 dimensions, the perimeter and the apothem, which creates a square. All right, we just have one more example. And if you want to try that example all on your own, you can. Okay, so go ahead and pause the video, try it. When you're done, start the video up again, follow through, and see if you got it right. All right, so now that you've tried the example on your own, we're going to do it together. So we have to find the area of the regular polygon given the following information. So this is not the apothem because it goes to a vertex and not a side length. The apothem is actually over here. Okay, this 10 is actually my radius. It goes from the center to a vertex. It's the radius of the regular polygon. So if I want to find the area of a regular polygon, again, our formula is 1/2 perimeter times apothem. So I got to fill those in. Okay, I don't have either the perimeter or the apothem, so I actually have to find both in this problem. Okay, I like to start with the apothem first. So again, with the apothem, I have a side length, I have A. So all I need to do is find my theta, and then I'll be able to use trig to find my apothem. All right, and again, to find theta, it's 360 over the number of sides divided by 2. So 360 divided by 1, 2, 3, 4, 5, 6 sides, and divide by 2. What happens is I get 30 degrees. So this is 30 degrees, and that's 90. So this has to be 60. I have a 30, 60, 90. So I'm not going to use SOHCAHTOA here. Because this is a special right triangle, you have to leave it in exact form, meaning no decimals. Okay, so it's the only time with polygons where decimals aren't okay. When you end up with a 30, 60, 90 triangle inside your polygon, you have to give me simplified radical form. Okay, so no decimals. All right, so I give you the hypotenuse. Okay, remember? And we want to find, this is the long side. So I have to go through the short side first. So I'm going to have to go from the hypotenuse to the short side. To do that, we have to divide by 2. So that makes this 5. And remember, these are equal, so it's also 5. Okay. Then I can go from the short side to the long, and remember that's multiplying square root 3. So this equals 5 square root 3. So my apothem is 5 square root 3. Okay. Now I have to find perimeter. So if we remember, perimeter is the number of sides times the side lengths. I know I have 6 sides. I need to know the side length. Well, when I found the apothem, I actually found my side length. Okay, this half is 5, this half is 5, so the whole side length is actually 10. Okay, this is going to be 10, which gives me 60 for the perimeter. So I put 60 here. And then again, you're going to multiply just the outsides together first. So I can take 60 times 5. And then I'll divide it by 2 for the half. And I get 150. And then you have the square root 3 left. So put that there, and then units squared. Okay. The special right triangle, so there shouldn't be decimals. Okay, and that's it for today.